Hey there, y'all. Today we're going to look at 7.6 on solving rational equations. In this section, you're going to be able to solve rational equations. And that falls under two standards for us in Algebra 2, AREI 2 and ACE 1. Now, here's what we're going to be able to do. We want to look at what is a rational equation and how do we solve it, right? Well, remember that a rational equation can be as simple as like 3/4 plus 5/7 is equal to what, right? And to be able to add those together, what do we need to have? Well, we need a common denominator. And so we need the same thing when we look at rational equations that have variables in them. And the process is going to be similar to what we've talked about earlier in this unit. So let's go ahead and look at example 1. So definition here, equations that contain one or more rational expressions are called rational equations. And remember, rational expressions are ones that have variables in the denominator a lot of times. And so when we look at this first problem here, we've got 5/24 plus 2 over 3x is equal to 1/4. Now there's two ways to attack this problem. We can get a common denominator for the 24 and the 3 minus x. And again, we talked about how to get that least common multiple before. Or, since the other side just has a number as well, we can move this over and make this a little bit easier on ourselves for this work. And so I'm going to show you how to move this over and then do it the short way in this case. And then example 2, we'll have to get a common denominator between two rational pieces. So here I'm going to subtract the 25/4 from both sides. And when we do that, we're going to get 2 over 3 minus x is equal to 1/4 minus 5/24. Now, what is the common denominator for 4 and 24? Well, that's going to be 24. So I'm going to multiply this fraction by 6 to the numerator and denominator. So we're going to get 2 over 3 minus x is equal to 6 over 24 minus 5 over 24. And remember that when you're subtracting fractions, we're going to keep that denominator. So there's the 24. 6 minus 5 is 1. Now, our next step here is to get rid of the fractions. And so we're going to multiply both sides by the two denominators. And so this side will get multiplied by 3 minus x. But remember, what we do to one side, we've got to do to the other, right? So we're also going to multiply this side by 3 minus x. And over here, this will cancel. And then we're also going to have to multiply both sides by the 24. That is the denominator on the right side. And that cancels that 24. And so what we're left with is 2 times 24, so that's 48. And we're left with 1 times 3 minus x, so that's 3 minus x. And so solving for x here, we're going to subtract the 3 and get 45. Is equal to negative x, and to get the positive x, we'll divide by negative 1. That gives us now the positive. And so x is equal to negative 45. Now, with these problems, we do need to check for extraneous solutions, and we're going to talk about that in example 2 as well. But we do need to check this answer and make sure it works out. So, coming back to our original problem, 5 over 24 plus 2 over 3 minus negative 45 is equal to 1/4, question mark. 5 over 24 plus 2 over, this is a double negative, so 3 plus 45, that's 48, is equal to 1/4. Common denominator here is 48. Or this 2 over 48 will actually reduce down to 24. And so 5 over 24 plus 1 over 24, because we're dividing here by 2 and here by 2, right? Because that can reduce. And then that's equal to the 1/4. Again, still checking. And then 5 plus 1 is 6. And so 6/24 is 1/4. And 6 divided by 6 is 1. 24 divided by 6 is 4. So this answer checks out. Okay. So again, when we're solving this out, make sure you're getting your pieces to each side to be able to solve this completely out. Okay. So again, there is another path here, and that would have been getting the denominator of 24 and 3 minus x to be the same. and then having to cross multiply that, your numbers are going to be a little larger, but you will come out to the same answer as long as all your steps are correct. So let's go ahead and look at example 2. So in example 2, we first want to talk about extraneous solutions. And remember, we talked about these back when we were dealing with radicals. But the same issue can come up with rational expressions, because we're going to introduce higher polynomial factors. So we might go from a quadratic to a cubic function, or a cubic equation, and we could introduce solutions that don't actually work. And we've got to check for these. Now, one way to know of certain values that won't work is to check your denominators. What values of the variable would not be possible because it's going to make it undefined. So let's look at example 2 to see that in action. So we first want to look at these denominators and know what can p not be equal to no matter what I do to this problem. Well, p plus 1 equals 0, so that's -1. And p minus 1 equals 0, so that's going to give us +1. And so p cannot be positive or -1. No matter what happens in this problem, if I get -1 or I get +1, I immediately throw that answer out the window. All right, so let's see how to solve this one. Now, again, a couple different ways you can attack this. You can get this p plus 1 and p minus 1 on the same side and deal with it that way. But in my opinion, the easier method is just to get this with a denominator here. And so what we're going to do to get that common denominator is that this would need a denominator of p minus 1. But if I'm going to put p minus 1 as the denominator, I also have to multiply that to the numerator. And so what we're going to get is p squared minus p minus 5. Do not worry about factoring anything at this step. If we've got a potential to factor, we will do it later. Plus, so this is going to be p squared minus p over the p minus 1. And so now we've got the common denominator. We can write it as one fraction and combine like terms that we've got. And so we're going to get p squared minus p minus 5 over the p plus 1. That is equal to 2p squared minus p and minus 7, because this is plus a negative, so it's going to stay minus, over the p minus 1. Now we're going to need to cross multiply, get each of these denominators away. And so when we do that, we're going to multiply both sides by the p plus 1. That's the denominator of the left side, so that will cancel here. And we'll multiply both sides by the p minus 1. And so that will cancel those. And then we need to multiply n. So there's some multiplication we've got to do. And remember that when we do this, all of this has to distribute here, and all of this has to distribute in as well. So we're going to get p to the third minus p squared minus 5p minus p squared plus p plus 5. That will be equal to us doing it on this side as well. And again, this will go in both, right? So again, we're going to hit 6 terms, and then we'll simplify and combine like terms, and then we'll go from there. So we're going to get 2p cubed minus p squared, and then minus 7p, and then we're going to get plus 2p squared minus p and minus 7. Combining our like terms on each side alone first, and then we'll combine them on one side. So we're going to get p cubed. I've got a minus p squared and a minus p squared, so that's minus 2p squared. Minus 5p and plus p, so that's minus 4p. And then we've got the plus 5 on the end. On this side, 2p cubed. Minus p squared and plus 2p squared, so that's plus p squared. Minus 7p and minus p will be minus 8p. And we've got the minus 7 on the end. Now, when we're dealing with a cubic function or a higher function, we want to set this equal to 0, see if there's a way to factor, see if there's a way to get this solved down into simpler functions, right? And we've talked about this back in Unit 2 and Unit 3 on how to solve these, and Unit 4 as well, on how to solve these. So in this case, I'm going to move everything from the left side to the right, because the 2p cubed is the higher of the highest power, the highest coefficient of the highest power. And so I'm going to move everything to the right side so that the 0 is on the left in this case. If you want to move the other direction, you can. That is personal choice. It's just going to have the opposite signs at this step. but do make sure that you are doing all your operations correctly. So this was positive, so I need negative. Negative needs positive, negative needs positive, and positive needs negative, and they match over here. So cancel, 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 cancel. We get 0, and so that's going to give us p cubed plus 3p squared minus 4p minus 12. Now we've got a 4-term cubic. The best method to solve this is to look at factor by grouping. And remember, factor by grouping is that we take the first 2 terms, see what they share in common, and we take the second 2 terms, let me get the right color here, the second 2 terms, and see what they have in common. And then we'll go from there. So what does p cubed and 3p squared share in common? Well, they have a p squared. What's left behind? Well, I took out 2 of the p's, there's 1 left. I took out both p's, so there's just the plus 3 left. From the second part, remember, you're always going to pull this sign and put it here. 4 and 12 share a 4. There's no other variable in common. So p, and then we pulled the negative, so it's now positive, and we pulled a 4, so that's going to leave us a 3. And again, all this is still equal to 0. And now, remember that we want this parenthesis and this parenthesis to be the same to do the next step. And because they're the same, we can do the next step, and that next step is going to take this piece and this piece. So the p plus 3, that's our first, and then p squared minus 4 is the other piece. Now, from here, remember that we're going to set each piece equal to 0 and solve for p. So I'm going to get that p is equal to negative 3, and I get p squared is equal to 4. So take the square root of both sides, so p, and remember that when you take the square root of something that was squared, you need what? That plus or minus, right? So we're going to get positive or negative 2. So these are my 3 potential solutions. Now, here's the issue, is that we have to check all 3 of these, and so that's going all the way back up to the start of the problem, all the way back up here, and checking negative 3, positive 2, and negative 2. And so just for example, if I plug in the negative 3, remember that's going to plug in everywhere. And 3 minus the 5 over the negative 3 plus 1 is equal to the negative 3 squared minus 7 over negative minus 1 plus negative 3. And again, there's a lot of negative 3's in this problem. There's a lot to simplify here. And so it is prone to mistakes. And there is a way to do this on the calculator as well. And if you'd like help with that, ask me. I just don't want to do it in the video right now. But there is a way to do this quicker in the calculator to test the values and see if it works or not. But again, I'll show you that in person or through like Google Meet. So we've got 9 plus 3 minus 5 over negative 2. Is that equal to 9 minus 7 over negative 4 minus 3? And so that's 12 minus 5 is positive 7 over negative 2. This is going to be 2 over negative 4 minus the 3. So this is negative 3.5. This is a negative 0.5 minus 3. So negative 3.5 is equal to negative 3.5. So it checks out. So the first one checks out. And I will tell you that, again, I could take time and show you the other 2. But I will also tell you that the positive 2 checks out and the negative 2 checks out. So all 3 of these solutions do check out and are all solutions of this equation. So again, you got to test them all, you got to work through them, but that is the method of getting there, okay? So again, if you got questions on this, ask, because it is a long process on some of these, but just go through step by step. Get your variable, remember you need 1 fraction on both sides, then cross multiply to get it canceled out, so that way you're dealing just with regular items, not any fractions left in it. And then you're able to solve from there. And again, sometimes it comes out to a cubic or quadratic, and you've got to use your proper methods for those, okay? So what we're going to look at now in examples 3, 4, and 5 are a couple word problems on how to use rational functions to solve some situations. So we're going to look at those. All right, a definition we need to look at first is a weighted average, and this is a method for finding the mean of a set of numbers in which some elements of the set carry more importance or weight than others. So for example, prior to the 2020-21 school year, remember that your grades were 50-50, 50% major, 50% minor. So you could just average the two numbers. Let's say that your major grade was a 90 and your minor grade was an 80. And so you would just average these two numbers and get an 85. But in the 2020-2021 school year, that changed. Your major grades are now 60% and your minor grades are now 40%. And so when we do these weighted averages, we have to multiply the value by this percent. So it would be the 0.6 times 90, because remember we have to change our percents to decimals, and it would be the 0.4 times 80, and when we add those together, well, this is 54, and this is 32, we get an 86. So you see that when the higher thing has more weight, it's going to cause it to be above just if we were doing a regular average of everything being equal. So let's see how that works in this mixture problem. So Aaron adds an 80% brine solution to 16 ounces of water, 16 ounces of 10% brine. And remember, brine is just salt water, and the brine percentage is how salty it is. How much of the solution should be added to create a solution that is 50% brine? And so there's a couple different methods you could do this, but I'm going to show you the easiest one for this problem. And it's actually not even a rational equation for this, but let's talk about how it works. So we've got the 0.8, right? And we don't know how much of that we're going to put into this solution. That's our unknown. Plus, we've got the 10% brine solution, of which we have 16 ounces, right? And that is equal to, we want a 50% brine solution. But how much water is going to be, or how much of this brine solution, when we measure the water, how much water is in there? Well, it's how much of the 80% solution we put in, plus how much of the 16% solution we put in, so it's x plus 16. Now, you're saying, wait a minute, this isn't a rational problem, right? Well, this is actually step 2, and there's again, a way that this can be written as a rational first. It's, again, a method that we could look at. But again, why go there when this is the easier process? So 0.8x plus 1.6, multiplying that out, is equal to 0.5x plus what's half of 16? That's 8. And so solving both sides here, we're going to subtract the 1.6. And we're going to subtract the 0.5x, combining two steps in one here. These cancel, these cancel. So we're at 0.3x is equal to 6.4. And then we can divide both sides by the 0.3. And when we do that, we're going to get 21.3 repeating. Now, what does x represent in this problem? That they would need to use 21.3 repeating ounces of 80% brine to make 50% brine. Now, that's only the case because we're adding to a 10% brine solution and we already had a pint of it, right, 16 ounces. So again, different values would mean that I have a different amount of the brine that I need to add. So that is a mixture problem, okay? Again, this could be written as a rational, and again, it comes back from the individual pieces at the start, but it's just easier to write it straight across and solve out from there, okay? Let's look at the next word problem. So in example 4 here, we're looking at a distance problem. And so Lila swims up for 5 hours in a stream that has a current of 1 mile per hour. She leaves her dock, swims upstream for 2 miles, and sorry that this was a typo in the problem, but it's 2 miles, and then she swims back to the dock. And so what is her swimming speed in still water? So this is a good one to draw a picture on. So we've got the water here, right? And if the water is flowing this direction, where's her dock? Is it on the left side of this river or the right as we're looking at it? The dock would be here, and she's going to swim upstream first before returning back. And the distance that she's going is 2 miles. Now, how do we set up this problem? So when we look to set it up, we need to understand that the current is affecting her in both directions, right? So when you're swimming upstream, right, it's your rate of swimming, R, minus the current, right? However much that's pushing against you. And when you're swimming downstream, it's your rate that you can swim or paddle or whatever you're doing. And then plus the current. Same thing happens with like airplanes and air. Like when you're heading LA to New York, you add the current to it because you got a tailwind and you got a headwind going New York to LA. So that would be what we set up for there. Now, we need to remember that distance is equal to rate times time. And so in this problem, we know the distance and we know the rate, and it's going to be equal to how long this takes. And so we're going to divide by r to both sides and get d over r is equal to rt. And so, because we know the total time. So when we write this out, we're going to take the part that goes upstream plus the part that goes downstream, and that's going to be our total of 5 hours. So the distance is 2 miles, right? That's how far she goes upstream. And the rate is the r minus the current, which is 1. Plus the 2 miles over her swimming downstream, so that's the rate plus 1, and all of that is equal to 5. Now, this is where we've got to now solve this rational equation. And so we've got to get a common denominator and deal with that. So to get a common denominator, it's just going to be these two pieces multiplied together. And so we're going to multiply this fraction by r plus 1, and we're going to multiply this fraction by r minus 1. I don't need to do anything to the other side at the moment because it's just a number over there. So multiplying this out, we're going to get 2r plus 2 over r plus 1 times r minus 1 plus 2r minus 2 over r plus 1 times r minus 1. That's the common denominator. That's equal to 5. And then so we're going to combine here. So we're going to get 4r, and the 2's will cancel because 2 plus negative 2 over, and if you want to multiply this out, you can. And this will be r squared minus 1, because this was a difference of squares. And that's all equal to 5. And so then, multiplying this over here, r squared minus 1, and remember what you do to one side, you got to do to the other, right? So this cancels this. So 4r is equal to 5r squared minus 5. We've got a quadratic, so that means we need to set it equal to 0 and solve the quadratic. So 0 is equal to 5r squared minus 4r minus 5. Now, we could try to x puzzle this. That's going to give us negative 25 and negative 4. Is there anything that's going to multiply to negative 25 and add the negative 4? Unfortunately not. So we're going to have to use the quadratic formula here. And again, go back to unit 3 for this. And so x is equal to opposite of b, so that's going to be positive 4 plus or minus b squared, so that's 16 minus 4 times positive 5 times negative 5 all over 2 times 5. So x is equal to 4 plus or minus the square root of 16. This is 25 times 4, so that's 100. And negative times negative is positive over 10. X is equal to 4 plus or minus the square root of 116 over 10. Now, this is where I want to talk about what this x, or in this case, really this is an r, can be in this problem. Because we're talking about the rate of how fast she's swimming. And so if she's swimming at a rate that's negative, she'd be going backwards, and that wouldn't make sense. And so when we take the square root of 116, that's between 10 and 11. It's closer to 11. And so if we do 4 minus 11, that's negative. And the denominator is positive, so negative divided by positive is negative. So the negative doesn't work in this case. 4 plus 10 point something divided by 10 is going to give us a positive. So that's the only solution I'm going to continue to work on because it's the only one that makes sense. And so the square root of 116 is 10.77 over 10. And so we're going to get 14.77 divided by 10, and so that's 1.477. And so 1.477 is her rate. That's her miles per hour that she swims at. Okay, and that makes sense in this problem. And again, we can plug it back in and see that it would work out. Okay, so the last problem we're going to look at is a job problem. And you might have seen these before where like one person can do this and one person can do this, and so how fast can they do it together? That's exactly what we're going to look at and see how to solve that one. So in example 5, we're looking at Yumi and Umi mow lawns together. Yumi, working alone, can complete the job in 4.5 hours. And Umi can complete the job alone in 3.7. How long does it take them to complete the job when they work together? And so this sounds like a complicated problem, but it's actually not. So there's one job that they're doing, right? And Yumi can do it in 4.5 hours. So one job divided by 4.5 hours. And again, you can calculate, okay, so you can do what percentage of the job in an hour or 2 hours, so on. Plus one job, right? Over, well, Yumi can do it in 3.7 hours. And what we want to know is how fast together they can do one job in whatever amount of time it's going to take them. And so it's literally that simple. It's one job divided by 4.5, and then one job divided by 3.7, and then one job between them over the time that it's actually going to take them. And so if you were told that they could complete 2 jobs in 7 hours, you would have 2 over 7. That would be the ratio you would put there. And so when we solve this out, we need a common denominator here, and the quickest common denominator is just to multiply these two numbers together. You're going to get 16.65, and so you're going to get 3.7 plus 4.5, because multiplying the 3.7 here and the 4.5 here, over the 16.65 is equal to 1 over t. So this is 8.2 over 16.65 is equal to 1 over t. And so cross multiplying here, we're going to get 8.2t is equal to 16.65. Divided by the 8.2, and we're going to get that t is equal to 2.03. And so what does t equal to 2.0 mean? It means together they complete the job in 2.03 hours. So again, it looks like a complicated problem, but it's really not. And again, it's not a complicated rational problem unless there's other mitigating things in the problem that make it more complicated. So that's it for today. I know this is a longer lesson, but a lot on rational equations here that we needed to look at. So if you got any questions, hit up the email, hit up the Google Meet. Otherwise, I will catch y'all next time.